Good afternoon, Star Algebra class. This is Mr. Morales, and I'm going to be giving you your lesson today through video. Now, today's topic is solving systems of equations with elimination. And I'm going to go ahead and kind of blow up the screen here a little bit so we get a better view and I can help you. Now, let's go ahead and look at problem number one. Now, first of all, systems means when you have more than one equation that you need to find a solution for. In this case, we have two equations that we see here. And these equations basically are lines on a graph. These two lines may or may not intersect at a certain point. What we're going to learn today is, without graphing, how we can find the place, if any, that two lines end up intersecting. And the way we're going to do it is through what's called elimination. That means you need to find an x and a y coordinate that makes both these equations true. It's kind of hard to do that, though, when you have two variables. So the goal is to get rid of either the x's or the y's from both of them so you can solve the equations and make them a one-step equation. Now, this first example is the most easiest kind, because what we have here is we have a negative 4x and a positive 4x. That's a big key symbol because we have here our opposite numbers, negative and positive integers. Whenever you have that, that's going to cut your work down by a lot, because that means when you combine these two equations, you're going to end up canceling something out. And let me show you what I mean. I am literally going to add this equation that I have up here on top, this whole equation, I'm going to add it to this equation down here. The way you do it is you add the stuff that matches. I'm going to add the stuff with x's, and then I'm going to add the stuff with y's, and then I'm going to add my answers. And something's going to happen. Here we go. Negative 4x plus 4x. If you have negative 4 and you add 4, you end up with 0. So I have 0 x's. Now I have negative 2y plus 8y. Negative 2 plus 8 is a positive 6y. The equal sign comes down. And then I have negative 12 minus 24 more. That equals negative 36. So now this equation reads as 6y equals negative 36. So all I need to do now is figure out what number times positive 6 will give me a negative 36. Well, if I divide both sides by positive 6, I get y equals negative 6. So there's my first coordinate. I know I'm going to have a set of points, an x and a y, that give me the place where these two lines cross. I know the y coordinate now is negative 6. Well, once you know one of the coordinates, all you need to do now is pick any one of these two equations. And I'm going to go ahead and just pick the first equation. Negative 4x minus 2y equals negative 12. I'm going to plug in the y that I got right here, this negative 6, this one right here, plug it in for the y I have right here. So now I rewrite this equation as negative 4x minus 2 times negative 6 equals negative 12. All right, I'm going to go ahead and multiply these two things out. Negative 2 times negative 6 is a positive 12. And then I'm going to go ahead and solve. I have plus 12 over here. I want to get rid of this plus 12, so I'm going to subtract 12 from both sides. This 4x will just drop down. This negative 4x, excuse me. Plus 12, take away 12 is 0. Equal sign drops down. Negative 12 minus 12 more is negative 24. So now my equation is negative 4 times x, or some mystery number, equals negative 24. I'll divide both sides by negative 4. And I get x equals, and negative divided by negative is a positive. 24 divided by 4 is 6. There's my x coordinate. So my solution tells me that these two lines, if I graphed them, they would intersect at 6, negative 6. That also means if I plug in a positive 6 for both of these, and I plug in a negative 6 for both of these y's here, then I will get these two individual answers. So these are the solutions that make both of these equations true. That's what solving a system means. What answers for x and y are the same for both of these equations that you have here. I'm pretty sure you guys didn't get that all maybe from just one example. So I'm going to go ahead and move to the next one, which is example number 2. So I'll go ahead and clear this out. And then I'm going to go ahead and shift over to problem number 2. So let's go ahead and do that. Now this one, actually I'm going to skip number 2 because it's just like the first one. And I want to get to one that's a little more interesting, and that's going to be number 6 down here. Now, There's other things you can do other than just straight up adding. You can also subtract equations. What that means is, like, look at number 6 here. Here I have 8x and minus 3x. If I add those two, they will not cancel out. If I add my y's, they will not cancel out either. But I have to think, well, I would like to let's say, get rid of these y's. Well, here's a positive y. If this was a negative y, they would cancel out. Well, you can make it negative. And the way you do that is you take whichever equation you want, and I'm going to multiply the whole equation times negative 1. So I'm going to leave my first equation alone, 8x plus y equals negative 16. And I'm going to rewrite the second one. I'm going to multiply the whole thing times negative 1. Because as long as you change everything the same way, the equation is still the same. Negative 1 times negative 3 is a positive 3x. Negative 1 times a positive y is negative y. Negative 1 times negative 5 is a positive 5. Now, like in the last example, I'm going to go ahead and combine my like terms. I'm going to combine the x's, combine the y's, and combine my answers. 8x plus 3x is 11x. A positive y, take away y, is 0. Negative 16 plus 5 is negative 9. Then I'm going to divide both sides now by 11. And I get x equals negative 9/11. All right, so there's my first coordinate. And yes, you can have fraction answers. All right, so now I got to plug that back in to this equation. And let me go ahead and do that. Just 1 second. All right, I need to make a quick little fix, and that was my addition I did right here. Negative 16 plus 5 is negative 11. So let me go ahead and switch all this out. That was kind of all scary and jacked up. Take this answer out over here. All right, so negative 16 plus 5 is a negative 11. And now I have 11x equals negative 11. I'll divide both sides by 11. That's a lot better to deal with than that crazy fraction. And I get negative divided by a positive is negative 1. So here's my x coordinate, negative 1. There's part of my answer. But I need to find the y. That goes right there. So I'll go ahead and plug in negative 1 for x. I'll just take this top equation again. 8x plus y equals negative 16. I know that x has to equal negative 1. So 8 times negative 1. I simply replace the x with the answer I just got, so I can help find my y value. 8 times negative 1 is negative 8 plus y equals negative 16. What would you have to add to negative 8 to get negative 16? You'd have to add 8 more negatives. So y must equal negative 8. And there's your other answer. So your answers for this one are negative 1, negative 8. What you should take from this is that you can manipulate equations by multiplying everything by negative 1 and in order to change the sign. So that way you have things that better eliminate. Sometimes you may solve an answer for x, and when you plug it in for the y, it doesn't work out. You may get an answer that doesn't make any sense. If that happens, then that means you have no solution. That means those two lines never cross. All right, so you have a couple of situations. You can get an x and a y. That means the lines cross, so you have a solution. You might get something that says something like an answer that says later on like 2 equals 2. All that means is that you really have the same equation happening. So if your letters, your x and your y, end up disappearing for some weird reason, and you get a statement that looks like this, like a number equals a number, or even something that looks like this, or something equals the same exact thing, that means the two lines are really the same exact line. If you get an x, but you can't get a y, or vice versa, that means there's no solution. Sometimes you will have some that have absolutely no solution, and that's possible, but you won't know until you've done all the work. I'm going to go ahead and do one more example with you, and let's go ahead and just try example number 3. So let me go ahead and clear my screen off everything, and let's go ahead and look at example number 3. Okay, example number 3 is a nice, easy example. Actually, I'm going to go to number 5 because that one's a little more tricky. So here we have x's. These two will not cancel out if we combine them. Here we have negative 9y's. Those will not cancel out. They'll just get bigger, more negative. And so what we need to do is figure out how can we manipulate one of these equations so that the y's cancel out. It could be y's that you cancel out. Sometimes it could be x. I'm going to actually try something a little different. I'm going to, no, well, I was, but I'm afraid it might be too complicated, so let me just stick to what I did before. I'm going to go ahead and try to make this negative 9 a positive. And the way I do that is I'll multiply everything in this equation times negative 1. Because when you multiply times negative 1, that changes all your signs. So I'll rewrite the first equation, and that stays the same, negative 2x minus 9y equals negative 25. I'll multiply everything by negative 1, which changes all my signs. So now I'll end up with 4x plus 9y equals 23. I'm going to go ahead and add both equations together. So I'll add the x's first, then I'll add the y's, and then I'll add my answers. Negative 2 plus 4 is positive 2x. Negative 9 plus 9 is 0. Equal sign just drops down. Negative 25 plus 23 is a negative 2. Now I just divide by the number that's with my variable, which is 2, and I will get x equals a negative 1. So now I know that in this solution, x has to be negative 1. Now I'll go ahead and pick up my first line again, and anywhere I see a negative 1 or an x, I'll replace that with negative 1 to help me find what y is. Negative 2 times negative 1 is positive 2. Minus 9y equals negative 25. This is a positive 2, so I'm going to subtract it to get rid of it from over here also. And that gives me negative 9y equals negative 27. Negative 9 times what number gives me a negative 27? Well, I know a negative divided by negative is going to be a positive, and 27 divided by 9 is going to be 3. That means my second number has to be a positive 3. And there's the solution to this system. So there you go. There's 3 examples. It is kind of convoluted, which means it can be kind of tricky, but it's not impossible to do. And you should have the skills, if you're in algebra, as well with a calculator, to do all this. For right now, your assignments are going to be just the odd numbers. So go ahead and just work on those for now. Make sure all work is attached or is very visible and legible on this paper when you turn it in. Good luck, guys, and go ahead and ask me any questions you might have if there's something that's unclear.